This is integration by parts. We have to find the volume. So volume equals to limit. So the limit is, suppose, x1 to x2 in Cartesian form, y square pi y square dx. So this is the idea. Now the first thing that we have to do, we have to have an idea of the limit. If you take a look at the question they have given the limit. Here it is 0 to pi, so we can assume that the limit is 0 to pi. So let me remove that and write down the limit again. So it's going to be 0 to pi. If I take the pi outside and write 0 to pi as the limit and y squared dx, I can consider this to be the integral. I can write pi 0 to pi, y square is going to be x square root of sine x whole squared dx. So we can write pi 0 to pi x squared square root of sine x whole square is only sine x dx. Now if I consider this to be the integral, I can write therefore v equals to pi I. It would be easier to write this. So therefore I equals to 0 to pi x squared sine x dx. So for integration, this is going to be LATE, A for algebra, so T for trigonometry, so algebra gets the priority. So this would be UV, U is x squared, V, so dV by dx is sine x, so V is going to be the integration of sine x, which is minus cos x, divided by chain rule, which is 1. So the limit is going to be 0 to pi, minus integration 0 to pi. Now V is going to be integration of sine x, which is minus cos x, and dV by dx is going to be twice x dx. So this would be, if I put the value of pi here, this would be pi squared, and cos pi is minus 1, so minus of minus 1, minus, if I put 0 here, 0 squared is 0. So this is going to be the integral if I put the limits. Now if I bring this minus outside, it would be plus. So this would be, if I bring the constant outside, so it would be 0 to pi x cos x. So it's always a good idea to bring the negative and the constants outside. So this would be pi squared plus 2. Now let's do the integration of this again. So LATE, x is the algebra, so u, v is going to be the integration of dv by dx, so this is going to be sine x. So the limit is from 0 to pi minus 0 to pi dv by dx, v is going to be integration of cos x, which is sine x, and the derivative of u is going to be 1 dx. Okay, so this would be pi squared plus 2. Now if I put pi here, it would be pi sine pi minus, if I put 0 here, sine 0 is 0, 0 is 0, 0 into 0 is 0, minus integration of sine x is minus cos x, and the limit is from 0 to pi. So this would be pi squared plus 2. This would be pi sine pi is 0, so this would be 0, so 0 minus 0 is 0, minus, so this would be, if I put pi here, this would be minus cos pi minus cos 0. So this would be the limit. Let me bring it out here. So that means pi squared plus 2. Cos pi is minus 1, cos 180 degrees minus 1. So minus, so 0 is 0, I didn't write that. So this is the minus and the bracket. So cos pi is minus 1, minus of minus 1 is 1, and minus cos 0 is 1, so this is 1. So the calculation is going to be, this cannot be 0, I think. Okay, I forgot to put a bracket here, there should be another bracket. So minus cos 0, okay, so this would be plus 1. So this would be pi square plus 2 into minus 2. This would be pi square minus 4. Therefore the volume would be pi I equals to pi square minus 4. this would be pi cubed minus 4 pi. That means you have to be very careful with the bracket inside the bracket inside the bracket. Perhaps it would be a better idea if you consider this as a separate I. Maybe this is I1 and this is I2, then you will not have these mistakes when you have too many brackets. So you need to remember, when you do the sum and you have integration by parts inside integration by parts, the brackets are very important.